All right, this is the last lesson of topic 17. In this lesson, we're going to be looking at combining some algebraic relationships to geometry and developing what are called coordinate proofs. So most of the proofs today will focus on the properties of quadrilaterals that we've been learning, and you will have to use prior knowledge of your formulas for slope, midpoint, and distance in your coordinate proofs. So here are those formulas that you'll be using today, and they're at the top of your notes here as well. These are definitely ones that you need to commit to memory and not have to look up each time you have to use them. So let's look at question 1 in our notes. We're going to try to classify what type of quadrilateral this is based on the information that we're looking at, and I'll go to the notes to do that. So we have a quadrilateral because it's 4 sides, and we're trying to classify it. So the first thing it's asking us to do is find the midpoint of segment AB. So remember, your midpoint formula is just averaging your x coordinates and averaging your y's. That means add them and divide by 2. So my x's are 0 and 4, so I'd have 0 plus 4 divided by 2. My y's are 2 and 6, so I'd have 2 plus 6 divided by 2. So my midpoint would be 4 divided by 2, which is 2, 8 divided by 2, which is 4, 2, 4. And we can see that point would be right here, which is on that segment, and it does cut that in half. We're also asked to find the slope of each of the 4 sides, and your slope formula is here, but since you're given a graph, the easiest way to do that is simply the rise to run ratio. Do remember that if a line goes uphill, it has a positive slope. If it goes downhill, it has a negative slope. So we can tell just visually looking at the segment AB that it's going uphill, so it will have a positive slope. So slope variable is m, so I'm going to say slope of segment AB, and I'm going to look at the rise to run. So remember, the rise is how much the y is changing. My y is going from a 2 to a 6, so it's going up 4. My run is the change in the x. My x is going from a 0 to a 4, so it's going to the right 4. Always simplify your slopes. You would never give it as 4 over 4. This would become 1. Let's look at the slope of segment BC. So look at it visually is going downhill, so I know my slope should be a negative number. So again, the change in my y, I'm going from a 6 to a 3. I'm going down 3. That's a negative 3 rise. But then I have to go to the right 4 to 6, 2 units. That cannot simplify, so I'll leave the segment of BC as negative 3 halves. Next, let's look at the slope of segment CD. It is an uphill segment, so it has a positive slope. Change in y is going from a 0 to a 3, so it's going up 3. And then my run, my x is going from 3 to 6, so it's also going over 3. And again, I would need to simplify that. 3 over 3 is simply 1. So finally, my last segment is the slope of segment AD. Visually, I can tell that line is going downhill, so it should have a negative slope. My y is going from 2 to 0, so it's going down 2. That's a negative 2 rise. My x is going from 0 to 3, so it's going to the right 3. So that will not simplify. Negative 2/3 is my slope. So part C says, are any of the slopes the same? Yes, we can see that the slope of AB and the slope of CD are both 1. So what does that tell you about those sides? Remember, if 2 segments or lines have the same slope, that means they are parallel. So we would know segment AB is parallel. Remember, that looks kind of like an 11, really close together. The segment CD, because they both have a slope of 1. The next thing we're asked to do is to find the length of each one of the sides. So we're going to be using the distance formula for that. So we'll need to find the length of AB, BC, CD, and DA. And so I'm not putting the segment bar above those because I'm talking about their measure. So leave that part off. So we're going to substitute these numbers into that formula, which is at the top of your paper there. It's the square root of the change in x. So I would have either 4 minus 0 or 0 minus 4. It doesn't matter which one because you're going to square it. It's going to become positive. and then your change in y. 6 minus 2 or 2 minus 6 does not matter, and we're going to square that. So remember, you can put that whole thing in your calculator. So second x squared gives me the square root, and I'm going to put in parentheses 4 minus 0, close parentheses, square it, plus open parentheses 6 minus 2, close parentheses, square it. And so it doesn't, we can give the exact number if it doesn't give us rounding rules. By not putting it in here, you would have to simplify that radical. So for what we're doing, it's fine to have the approximation, which is 5.7. But if you're on your homework, you're probably going to have to give that in exact measurements, so you'll have to simplify this. So let's do that together. 4 minus 0 is 4. 4 squared is 16. So I have the square root of 16 plus 6 minus 2 is 4. 4 squared is 16. So we would have the square root of 32. We would need to simplify that. 16 is the largest perfect square factor of 32. 32 is 16 times 2. So we could take the square root of the 16 and bring it out as a 4. So the exact length is 4 square roots of 2. You'll see if you put 4 square roots of 2 in your calculator, you're going to get that same decimal we had as our approximation before. All right, let's look at BC. So we have the square root of the change in x. So 4 minus 6 or 6 minus 4, either way. And the change in y, 6 minus 3 or 3 minus 6. And again, the order doesn't matter because of the squaring. If we weren't squaring, then we would certainly need to be consistent in our subtraction order. So 6 minus 4 is 2. 6 minus 2 squared is 4. So we have the square root of 4. I'll do that over here. So 6 minus 4 is 2. 2 squared is 4. Plus 6 minus 3 is 3. 3 squared is 9. So we get the square root of 13. That's the exact distance. So CD, we're finding the distance for that is the square root of the change in x. So 6 minus 3 or 3 minus 6 squared plus 3 minus 0 or 0 minus 3 squared. So 6 minus 3 is 3. 3 squared is 9. 3 minus 0 is 3. 3 squared is 9. So we get the square root of 18, which is 9 times 2, and take the square root of the 9 and bring it out as a 3. So this is 3 square roots of 2. And then DA, we'd have the square root of the change in x, 0 minus 3 or 3 minus 0 squared, plus the change in y, 2 minus 0, 0 minus 2 squared. So 3 minus 0 is, I'll do that over here, 3 squared is 9. 2 minus 0 is 2. 2 squared is 4. We get the square root of 13. So we found the length of each sides, and we're going to name any that have the same length. And so we do have two that have the same length. BC and DA were both the square root of 13. So you have two ways of writing that. You can either say BC equals DA, or put the segment bar and use a congruent symbol. So remember, numbers are equal, segments are congruent. So now we should be able to classify this quadrilateral. We have these sides AD and BC that I can put tick marks on to show that they're congruent. And then AB and DC, remember, had the same slope, so they were parallel. So if we only have one pair of parallel sides, remember that cannot be a parallelogram. It has to have two pair to be a parallelogram. One pair is a trapezoid, but this is a special trapezoid because our legs are congruent to each other. So we should be able to classify this quadrilateral as an isosceles trapezoid. You have some additional notes on this page. Back here, this is great if you're stuck at trying to tell what type of quadrilateral you are having. This kind of steps you through all the different ways that you could prove what type of parallelogram it is or what type of quadrilateral it is. There's also all the features of the special quadrilaterals that we have learned here. And so you can see an isosceles trapezoid has one pair of opposite sides that are congruent. So one pair, it doesn't, I don't know why it doesn't say that one pair is parallel. So you'd have a pair of parallel sides and then a pair of opposite sides that are congruent. And of course they wouldn't be the same pair that you're talking about. the parallel sides would not be the congruent sides in an isosceles trapezoid. All right, so let's look at number 2. It says to sketch, let's see where we are in our, sorry, just a moment. We've answered all of question 1. So, okay, the different types of proofs we've studied so far are called flowchart and 2-column proofs. So coordinate proofs look a little different. We just did a coordinate proof. Coordinate proofs means you're using the coordinates, obviously, to prove something is true. So let's look at question 2 now. First thing we need to do is sketch quadrilateral ABCD. So A is at 2, 1. Definitely need to make sure you plot your points right, or you're going to be messed up from there on. So remember, the first number is your left to right movement, second number is your up and down movement. So right 2, up 1. And I'm going to label that A. And then B is at 4, 2. So right 4, up 2. C is at 3, 4. So right 3, up 4. And D is at 1, 3, right 1, up 3. So it's a quadrilateral. We'll definitely need to connect those points together. And so does it look like it's a special quadrilateral? It looks like it might be a square to me, is what it looks like it is. But remember, we don't go by looks. We definitely have to have information to support our answer. So if you'll notice on the back notes, it tells you one way to prove what type of quadrilateral it is. Every single time, you can always identify your quadrilateral by finding the slopes of all 4 sides and the lengths of all 4 sides. If you do that every single time, you will have enough information to prove what type of quadrilateral it is. So that method works every time. So that's what we're going to be doing here. We're going to be finding the lengths of all the sides and the slopes of all the sides. And then we should be able to tell what type of quadrilateral it is. So go ahead and do that on your own. Find all 4 lengths and all 4 slopes, and then you can pick up with me and see how you did. Okay, so these are the distances you should have found with your distance formula. Remember, the order of the subtraction doesn't matter because you're going to square it. All of those numbers should be positive underneath the radical. So you should have gotten the square root of 5 for all 4 of your side lengths, which means all 4 of these sides are congruent. Now remember, that's not enough information to say it's a square. What else could it be at this point? Hopefully you recognize it could be a rhombus. So a rhombus also will have all congruent sides. So that's why it's necessary to do distance and slope. So slope, remember, will tell you if you have parallel sides. It'll also tell you if you have perpendicular sides. So same slope means parallel. Opposite reciprocal slopes mean perpendicular. So we can see we have 2 pair of parallel sides. So this side is parallel to this one, and this one is parallel to that one. That would make it a parallelogram. Still don't have enough information to say it's a square. But when we look at the consecutive slopes, 1/2 and -2, they are opposite reciprocals of each other. They have opposite signs, and they are the flipped fraction. Same here, same here, same here. So since you have those 4 sets of perpendicular relationships, you have 4 right angles that you can add to your drawing because of those perpendicular sides. So now that the opposite sides, or all 4 sides are congruent and all 4 angles are congruent, now we can classify this as a square. If it just had this feature and not this one, just congruent sides, it would be a rhombus. If it had the opposite reciprocal slopes and not congruent sides, remember that would be a rectangle. But since it has both, it is a square. All right, so that is it with our examples. There are other ways to prove that as a square, by the way. We could have used the diagonals. If you'll prove the diagonals are congruent and perpendicular, then that means it has to be a square. I could also have drawn a diagonal and shown that those 3 sides follow the 45, 45, 90 rules. Okay, so make sure you show all of your work on your homework, and be careful. 1 through 4 is using the points A, B, C, D, but after that you're using the points Q, R, S, T that you come up with for the answers. All right, good luck.